Hi class. In this video we're going to be talking about section 2.3 linear equations. And now we already started to look at some of these, particularly when we were graphing in our last video and when we were introducing functions and things like that in a previous video. So what we're going to do today when we look at linear equations specifically is we're really going to dig into some of the features of linear equations, some of the properties or characteristics, and then really digging into their graphs. So really focusing on this notion of graphs of equations, and that being the plotting of all the points that are solutions, right? Those values that make it true. And so I'm going to go to an image next, but I want you to have two questions in mind. What do you notice and what do you wonder? And after I show it, you might consider pausing it and really looking in and seeing, do you notice any patterns? Do you notice anything, any kind of associations? And maybe what kind of things do you wonder? And so here's that image. And now all of these are of the form y equals m times x. So we have y equals 3x, 2x, x, which is the same as 1x, 1/2 x, and 1/3 x. Here we have y equals 0, or 0x. And then we have a negative 1/3 x, negative 1/2 x, negative 1x, negative 2x, negative 3x. And then our y-axis here is x equals 0. So maybe pause here and take a minute just to look and see if you notice any patterns. Okay, so the first thing I want to point out is all of these lines in blue have a positive number in front of our x, whether it's a third, a half, 1, 2, or 3. All of those have a positive number in front of x. Now m, this is the coefficient of x, is called the slope. And I'll give you a formal definition of slope in just a little bit. But this number in front, this 3, 2, 1, half, and a third, is slope. And all of these blue ones, as we go from left to right along the line, they rise, right? So they rise, they go up as we move left to right. Some of them rise faster, and some of them rise slower, but all of them from left to right, they rise. So left to right, a positive slope line rises. And then if we contrast that here with our red ones, from left to right, no longer are they increasing, but they're decreasing. So we say they fall. So left to right, negative slope lines fall. So positive rise, negative fall. Our horizontal lines, for example, y equals 0, and we could draw another one at say y equals 6, would move left to right. And so horizontal lines have slope equal to 0. And then for vertical lines, that's like our y-axis here. Notice they don't have an m at all. Here we just have x equals 0, so there's no y term. Or over here we would have x equals 6 being a vertical line, because that's all the points where its x coordinate is 0, because the origin is 0, 0. Or over here where all of their x coordinate is 6, right, would be a vertical line there. So for vertical lines, slope is undefined. So let's be a little bit more formal about slope. So we'll define slope as the steepness between 2 points. And now let's say those points are x1, y1, and x2, y2. So slope we say is the rise over the run. That's the change in y over our change in x. And now just for notation, the capital letter delta, the Greek letter delta, stands for change, so change in y over change in x. And we can calculate that by doing the second y value minus the first y value over the second x value minus the first x value. Now let's put that into practice. And I'll draw a picture to help us kind of see that. So let's say find slope between 0, 4 and 2, 0. And so if we would draw that, x equals 0, y equals 4. That's our point 0, 4. And 2, 0 is here. And so the line we're looking at is there. And so thinking already, based on our pattern we noticed here, left to right, it's falling, so it should be negative. So slope should be, and we'll just put that in parentheses, negative. And that'll be some way for us to check our work when we get to the answer. So our formula up here says our slope is our rise over our run. Our change in y over change in x, or y2 minus y1 over x2 minus x1. So let's go ahead and just give these names. I'll call this x1, y1, x2, y2, just to help us keep that in order. So our slope is change in y over change in x, y2 minus y1 over x2 minus x1. y2 I said was 0, minus y1 is 4 over x2 is 2, x1 is 0. 0 minus 4 is negative 4 over 2, negative 2. And you're like, well, how can I see that in this graph? Now let me find my other pens, which I think are behind my laptop. They are not. Oh, they're over here next to me. If I remember when we talked about the distance formula, we drew our triangle in, and we said, well, this change is going to be y2 minus y1. And this one here is going to be x2 minus x1, right? It was that distance between our x coordinates and our y coordinates. And so because we do the vertical distance over the horizontal distance, rise is our vertical distance or change, and run is our horizontal distance. Right? And so this is where this notion of rise over run comes from. And what this tells us is for every unit we go down 2, we go right 1. So that means if we go down 2, right 1, down 2, right 1, right? Notice how all 3 of those points then fall on that line. So when we were plotting points to graph our equations, we just found a bunch of points, put them on there, and connected them. But now that we have this notion of slope, we have a new way that we can plot points. And that's by plotting a point. So suppose I didn't already draw my graph. And I'm going to plot, go ahead, this point 0, 4. 1, 2, 3, 4. And my slope is negative 2 over 1. So I'm going to go down 2, right 1. So put a little tick mark so we know we're at 1. And then we'll go down 2, right 1. Put a point. And if you want, we could go down 2 more. Right 1 more to 3. We can connect those points. And so that's how we can plot a line with slope. Now let's go ahead and do one more example. So we have slope between half, a quarter, and 0, 2. Well, m is change in y over change in x. y2 minus y1 over x2 minus x1. So let's give these names. y2 is 2 minus y1 is a quarter over x2 is 0. So y2 minus y1 over x2 minus x1, 0 minus 1/2. And then we can go ahead and calculate that difference. Get common denominator, we have 4 is our common denominator, so 4 times 2 is 8 minus 1 over 4 over negative 1/2. 8 minus 1 is 7/4 over negative 1/2. We can multiply the top and bottom by 2 over 1. That'll cancel to 1. This 2 and this 4 will cancel to a 2. We have negative 7 halves. Negative 7 halves. So m is negative 7 halves. And now we can go ahead and see if, do we agree? Should our slope be negative? So here we have 0, 2, 0, 1, 2. And here we have a half, a quarter. So if that's 1, this is a half. That's 1, a half, a quarter. With something like that, left to right. It is negative, so we know that our sign's good, and we can be content with our negative 7 halves. So suppose we were interested in when lines were parallel. So if steepness, right, if slope is a measure of steepness, all of these lines with slope 1 would be parallel. And so let's look at an example. It says, find the equation of the line. Find equation of the line parallel to a line with slope -2 and passing through -1, 3. First, I want to give us a fact, and I'll go back to my first page to write this. Parallel lines have the same slopes. So every line that's parallel to -2 is going to have a slope -2. So we'll go ahead and write in our y equals -2x line first. So when x is 0, y is 0. When x is 1, y is -2. So we go down 2 over 1, down 2 over 1. If we go backwards, up 2, left 1, up 2, left 1. And then let's see if I can draw that successfully. That's our line y equals -2x. So if we have some other line going through -1, 3. So x is -1, 1, 2, 3. So we have this point, and our slope is -2. So down 2, right 1, down 2, right 1, down 2, right 1. Or from here, up 2, left 1. And I'm going to use a different color pen. I'll use red to connect these. Oh, I missed it. There we go. What do you notice is true? Oh, that point should be there. I was like, something doesn't look right there. I'll white that out if I can figure out where I put my white out. What's in front of us? Go on a trip. Because, right, we know that linear equations give us straight lines. So I knew that something was wrong with that picture. And what happened is when I went up 2, I accidentally skipped 1 and went up 3. So it's maybe a little hard to see, but notice between every point and the one that plotted above it, we have a difference of 1, right? Our y value is 1 more than the original. So we have something that looks like y equals -2x, but our x value, or our y value, for a given x value, so here at x equals 0, in our original, y equals 0, but in this one, when x equals 0, y equaled 1. So we have to add 1. Or here when x equaled -1, we were at 2. But over here, we need to be at 3. So -1 times 2 is -2 is +2, plus 1 is 3. And so it's important that I give you a equation or a form for our equations. So generally speaking, we have something called point slope form. And point slope form looks like this. Y minus y1 equals m x minus x1. And we have another form, and we're going to spend time looking at these, but I want to give them both to you now. And then this one is called slope-intercept form. Here we have something that looks like y equals mx plus b. And b is just some constant. Right, so we know that x1 and y1 are our point. And in both cases, we know m is slope. But in our slope-intercept form, we have some constant. And notice that that's exactly what that 1 was. It was a constant. We had y equals our slope, because remember, parallel lines have the same slope, -2, -2, plus our constant of b. And so we were up 1 higher in every case. So let me go ahead and do another example. Here we have parallel to the line joining. Looks like -2, 1, and 3, 5 through 1, 2. So go ahead and plot that. X is -2, y equals 1, -2, 1. X is 3, 1, 2, 3, 1, 2, 3, 4, 5 is our y value, and we connect those. And so we can use either of our forms. I'm going to go ahead and use point slope this time. I need a point, an x1 and y1, and a slope. Well, this is our x1, y1, but we need slope. M is our change in y, or change in x, And here we get, so let's do 5 minus 1, 5 minus 1, over 3 minus a negative 2. 3 minus negative 2. So 5 minus 1 is 4. 3 minus minus is plus 2. 5. So our slope is 4/5. And so if we want to use either of these forms, let's say point slope form, y minus my y value, 2, equals m, which is 4/5, x minus x1, 1. And if you want, we can go ahead and simplify this, because you're like, that doesn't look like our y equals mx, right? Like, where's our constant? So let's do a little bit of work with this. I'm going to bring it up here. Y minus 2 equals, and then distribute 4/5. 4/5 x minus 4/5. I'm going to add a 2 to both sides. Y equals 4/5 x. 4/5 plus 2, well, 2 is 10/5. 10 minus 4 is 6, plus 6/5. And so see, when we have it in this form, we can see that slope we found, 4/5, is in fact our slope here. But this also shows us that our two forms, our point slope and our slope-intercept, are equivalent. And so let me go through a couple more examples just working with point slope form, and then just working with slope-intercept form, and then we're going to come back to perpendicular lines. So here we have point slope. Point slope, right? That was our y minus y1 equals m times x minus x1. Says, given a point and a slope, a point 0, 9, and slope m equals -2. Find the equation in point slope form. So find equation in point slope form. Actually, if you want, we can go ahead and start abbreviating this as point slope form. So given a point 0, 9, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I almost went high enough. 0, 9. And slope -2, so that means we go rise over run. We go down 2, right 1, down 2, right 1, down 2, right 1, 2, right 1, and so on, and we connect it. So this is the line for which we're finding the equation. Right, because if we look at one of these triangles, we go down to right 1. Our equation is point slope form is y minus y1, m x minus x1. So y minus y1, so x1, y1, y minus 9 equals m, or -2, x minus x1, x minus x1. And now that's just 0, so we have y minus 9 equals -2x. And that's as simple as that. And you know, we have to do a little bit more work if it hadn't given us the slope. So suppose we're given 2 points, -1, -3, and 6, -9. Let's go ahead and plot those 2 points, -1, -3, and 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, those, that's our line of interest. And what we want to do is find our equation in point-slope form. So we have a point, and well, we actually have two of them. And so we need our slope. M is change in y over change in x. So y2, negative 9 minus negative 3 over 6 minus negative 1. Negative 9 minus a minus is plus 3. Negative 6 over 6 plus 1 is 7. Our slope is negative 6/7. And so using our form, y equals y1, or y minus y1 equals mx minus x1, we have y equals, y minus y1, negative 3, equals m, negative 6/7, x minus, and since I picked this y value, I need to pick this x value, negative 1. Simplify that a little bit. Minus a minus is a plus. Y plus 3 equals negative 6/7. X minus minus is a plus 1. You're like, well, so you picked that point. Well, can I pick this point? And you absolutely can. In that case, it would look like y minus a negative 9 equals m, negative 6/7 doesn't change, x minus 6. Again, minus a minus, so y plus 9 equals negative 6/7 x minus 6. And so we have something that looks like that. And when we get to slope-intercept form, we can see why those are equivalent. So let's go ahead and rewrite this as slope-intercept form. So we have y plus 3 equals, distribute this, negative 6/7 x minus 6/7. And then we're going to have to go ahead and subtract that 3 over. And here we have, I'm running out of room, so I'm going to write it up here. Y equals negative 6/7 x minus 21 plus 6 is 27 over 7. So we have minus 27 over 7. And then let's go ahead and look at this one here. What we end up having is, I'm going to bring it up here if that's okay. Y plus 9 equals negative 6/7 x plus 36/7. Right? Negative 6 times negative 6 is positive 36/7. Subtract a 9 from both sides. Y equals negative 6/7 x. And I'm going to show my work for getting a common denominator. So 9 sevens are 63. So we have minus 63/7 plus 36/7. So 63 minus 6 is 57. 47, 37, 27. So y equals negative 6/7 x minus 27/7. And in both cases, we get the same number. So even though our point-slope forms down here, y plus 3 equals negative 6/7 times x plus 1, and y plus 9 equals negative 6/7 x minus 6, look different, when we convert them to slope-intercept form, our y equals mx plus a constant form, we end up getting the same value. And so since point-slope form isn't unique, right? Like the same line can have a different form or equation depending on which of these reference points we use. We sometimes prefer to use our slope-intercept form because a line will have only one way to write its value. And so let's go ahead and work with slope-intercept a little bit. And if you want, you can call this slope-intercept form, right? MB, so we have our point M form and our MB form. It's our slope-intercept, so it's this given. A point, -1, 0, M equals 2/5, given a point and slope. We have y equals mx plus b. Let's go ahead and graph it. So we have x equals -1, y equals 0. Our slope is 2/5, so that means we go up to right 5. Up to 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. At the very edge. Work backwards down to left 5. 1, 2, 3, 4, 5. And we can connect those, and we get something that looks like that. So to find our slope-intercept form, we have to substitute our slope. So we have y equals 2/5 x plus b. But we know that this point, -1, 0, our x and y values, make this equation true because this is a solution. Remember, all of our points on our equation or our graph are solutions to our equation. And so we can substitute -1 in for x and 0 for y and see what we get. So here we have 0 equals 2/5. X is -1 plus b. 0 equals -2/5 plus b. And solving for b, b equals 2/5. So if we take our general form, our slope, and our intercept, and bring them together, we get y equals 2/5 x plus 2/5. You might be wondering, intercept. Remember, we talked about intercept as being the points where it hits the axes. So what is this intercept? Well, suppose, and let me use blue. So say let x equals 0. We have y equals 2/5 times 0 plus 2/5. We have y equals 2/5. So that means the point 0, 2/5 is on the line. So our point 0, 2/5 is on the line, and that's called our y-intercept. And so that's why we call this slope-intercept form, because it turns out that b is our y-intercept. So we have our point slope form was our previous one, and then this one's called our slope-intercept form because this b term is always our y-intercept. And so we can go back here. Remember we had -27/7. Well, 3 7s are 21. And then we have 6 7s left, so almost 4. So if we go down 1, 2, 3, and this intercept is at almost 4. So that is at the point 0, -27 sevenths. And so when we use our slope-intercept form, we know our slope and we know our y-intercept. And so we'll go ahead and look at one more example. But now we're going to be given 2 points, 4, -7, and 5, 3. So we have our m is change in y over change in x. We'll do 3 minus a negative 7, 3 minus negative 7 over 5 minus 4. 3 minus a minus is a plus. 3 plus 7 over 1 is 10 over 1. So m is 10. Y equals mx plus b. Y equals 10x plus b. And then we can pick either point, because based on our work on the previous page where we were looking at slope-intercept, remember point slope, or when we were looking at point slope on the previous page, we showed that slope-intercept is unique. So pick either of these points, and I'll actually show you that both work out. We'll use this first one, so x and y, so negative 7 equals 10 times 4 plus b. And then our other one, so we have 3 equals 10 times 5 plus b. So here we have negative 7 equals 40 plus b. B is negative 47. And work out this one on the right. 3 equals 50 plus b. B equals negative 47. And so bringing those together, we know that m is 10. So y equals 10x minus 47. That also means when x is 0, y is negative 47, which is going to be somewhere way down here off the page. But we can plot our 2 points. X equals 4. 1, 2, 3, 4. Negative 7. 1, 2, 3, 4, 5, 6, 7 right there in my equation. And 5, 3. So we had 4, 5, 1, 2, 3. And so notice how with this 10, from left to right, it's really increasing. It's going up 10 and right 1. And so if we consider that back on this graph, so we had 1, 2, 3, that means 10 is something like nearly vertical. And so think about how as your number gets larger, it becomes steeper and steeper, or as it becomes a fraction, it becomes shorter, or less steep and less steep. All right, now I promised we would go back and look at perpendicular lines. And the reason I did that is because I thought it would be worthwhile to do a little bit more with our equations before we went through. So remember, parallel lines have same slope. So suppose we're finding a line. Find the equation of the line perpendicular to negative 2x plus y equals 14. That goes through 0, 2. Well, first let's go ahead and plot our original. So to get that, we have y equals 2x plus 14, which means when we have x equals 0, y equals 14, let's go ahead and pick something maybe at like negative 5 when x is negative 5. 2 times negative 5 is negative 10, so we have negative 5, 4. And negative 6 times 2 is negative 12. So we have negative 6, 2. 1, 2, 3, 4, 5, 6, 1, 2. And negative 5, 1, 2, 3, 4. Which we could have seen because our slope is 2. We go up 2, right 1, up 2, right 1, up 2, right 1, and we end up with this, right? And so you believe that 0, by the time you get to 14, would be somewhere up there. Now we want it to be perpendicular. Now perpendicular means they meet, so perpendicular means they meet at a 90-degree angle. So if parallel would look like this, perpendicular is going to look like this. And you're like, well, how do I know if something is perpendicular? So lines are perpendicular. So how about two lines with slopes m1 and m2 are perpendicular if m1 times m2 is -1. So the product of their slopes is -1. So what was our slope here? Our slope was 2. So m1 was 2. So we need to use this equation to find m2. So we have 2 times m2 equals -1. And that means m2 is -1/2, right? Just divide both sides by 2. m2 equals -1/2. But we still need to find perpendicular through 0, 2. So do y equals m -1/2 x plus b, 0.02. So y equals -1/2 times 0 plus b. Well, 0 times a half, whether it's positive or negative, 0. So b equals 2. That means our equation is y equals -1/2 x plus 2. So let me go ahead and draw that up here. So we said that this plus 2 was always our y-intercept. You can't see it, but 2. And then rise over 1, we'd go down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2, up 1, left 2. And if we connect those points, notice we have precisely a right angle. So to bring some of these ideas together, and I'll just kind of give you a little summary of what we've talked about. Slope is a measure of steepness. We talked about how if slope is positive, from left to right it'll go up, and if it's negative, from left to right it'll go down. We have two forms for linear equations. We have point slope and slope-intercept. So point slope, slope-intercept. And the point can be any point on the line, and B is always our y-intercept. Point or slope-intercept form is unique, and point slope is not. Parallel lines have same slope. perpendicular lines, M1, so with slopes M1 and M2 have the property that M1 times M2 equals -1. We can use slope to draw a point, or to draw an equation. So use slope to draw graph, rather, of an equation. And we need either 2 points, or if we have point slope, right here, 2 points, we can find slope. But if we have point slope or slope-intercept, we have slope directly. And we showed that point slope and slope-intercept really are the same forms. It's just using a special point, the y-intercept. And then what we have last is just kind of, and I didn't talk about this, but I want you to know that we can also think of slope is the rate of change of y with respect to x. That is the change in y. Remember, we wrote that delta y for 1 unit change in x. And so that's just another way we can interpret slope. So for this homework, you'll be looking at working with points, point-slope form, slope-intercept form, either finding slope when you have 2 points, identifying the slope of a parallel or perpendicular line, or graphing given this method. Have a great day, everybody. I'll see you in the next video.